Okay, thank you so much for your attention. I will always start my slides with a picture, more or less defining what I'm going to talk about. And I'm going to talk about my journey in research in the last 10 years. So I put this slide about Phineas Fogg, in a Spanish cartoons on the 80s. So this is applied machine learning to indoor and seamless localization of positioning. I'm Joaquín Torres. Here you have my contact information in case you want to expand or comment about this work. I would like to start with this slide. Do you know what is this slide depicting? None of you? This is the Sputnik. Sputnik, yeah. This picture is around 75 years old. But we are having in our pockets some technology that is inherited from this satellite-based communication. Because we have smartphones in our pockets, but because we are using GPS. The Sputnik was released 75 years ago. Then the Americans deployed NAVSTAR program. NAVSTAR program became GPS. And in the 1984, it was used in civilian applications, not by end users, but in civilian applications. And with an offset in localization, so that the accuracy was not that great as it is today. But it changed around 20 years ago with the development and the opening of GPS to real end users. Who recalls TomTom navigators in the cars, driving you to your destination easily with high accuracy, in part because of the map matching approaches embedded in the algorithms. But now, GPS is not perfect. We are used to get perfect location, but it has some challenges. Challenges in terms of how the signal is propagated in the atmosphere and different weather conditions. But at the end, you have good location accuracy. But there are other domains where machine learning and artificial intelligence can be useful, like in jamming and spoofing. In jamming is when someone with an illegal device is saturating the signal to avoid you to get correct location. And with the spoofing, it's something similar but a bit different, because it's someone with another illegal device trying to let you know that you are in a different location, so trying to say you are here when you are in a different place. But my work is not about GPS or outdoors. And remember that word, GPS, because when we talk about location, sometimes we say GPS, but it's not GPS, it's Global Navigation Satellite Systems, because we have also GLONASS, VII, and others, like Galileo, European Union. But the game changer was this picture. In 2007, I saw a similar picture here in the museum at UPV, because the iPhone, but not only the iPhone, was released. We have a computer nowadays in our pockets. And if you just open the map application, you can see the blue point in this building near this location, right? But we don't have GPS coverage here because we are indoors. But fortunately, we have this and we have that, which are the Wi-Fi access points. So when you are using the location services on your phone, you are not only using GPS, you are using also that information. They know where the routers, the Wi-Fi APs are located. Somehow they build a radio map based on that information, and they can set, or they can say, or they can provide you your XY location, even indoors. Look, when you are using Google Maps, they are saying, okay, are you visiting that restaurant? Because they know you are inside, because of that additional information. But indoor spaces are complex. We have this industrial facility we had at the University of Minho, with high height and metallic obstacles, industrial-like scenario. But then we have conference room like that one in the picture, plenty of people, or this one taken this morning. And the challenges they present are different. For instance, if I set up an indoor location system here in this room this morning, it will behave now totally differently, because you are here and you are disturbing the radio frequency, especially the bands that are being used by Wi-Fi or Bluetooth low energy techniques, which is the 2.4 gigahertz band. So we need to adapt those systems to any scenario, but also to any conditions within the scenario. So apart from that brief introduction, I will introduce myself. I'm Joaquín Torres. I was working on neural networks for my PhD thesis from 2003 to 2011, when the PhDs were not just 3 years. It took me 8 years to finalize my PhD. Then I moved to the knowledge engineering group in 2012, and there was this big crisis in Europe, especially in Spain, and I got unemployed. So I was looking for my future, and I got the opportunity to join the Geospatial Technologies research team in Castellón, and because they had to develop an indoor location system for smartphones for a company. And it was a project for 9 months. And I was there almost 10 years. So for a 9-month project, I stayed there for years because there was a promising research line. Then in 2020, I moved to the spin-off company, UBIC, but I feel like I have to move abroad. I mean, it's good to be at home, but sometimes you need to fly away to get some new feedback, to get new training, to know other people. So I applied twice to the Marie Curie, and I failed. And the third time I applied, I got it with 100 points, because I have more experience. So I spent 2 years of my life in Portugal, in the north of Portugal, in a wonderful city of Guimarães, next to Porto. I was living in front of the castle where Portugal was born. And that adventure finished in 2023, and I had the option to select the future, going to Huawei, to come back to Spain, or to continue in Portugal. And then when I was deciding, I got the good news that I got a citizen grant from the Generalitat Valenciana, from the regional government, to develop a 4-year project and get permanent position here in the Valencian system. So since 2024, I'm working at the Universitat de València in Burgessot, working on industrial indoor localization. And you can see me, how I have evolved in the last 10 years. So I'm a bit older, I smile a bit less, but I see that the challenges I had 10 years ago about research are still there. We still don't have a whole solution like GPS indoors. We don't have a universal solution that is working here, at the convention center, or at industrial facilities. Just to put you in context, I'm organizing every year an indoor localization competition with smartphones, so that I collect the data, I provide to the researchers, and they have to provide me the solutions. I'm doing that since 2014, and it has been a huge success. And this is reported in several papers with more than 100 authors, which is a nightmare to manage. Trust me, I submitted and I managed all those papers. But it was nice because we can see the different approaches from different research teams, all of them using machine learning to overcome the same problem, indoor localization with smartphones, or with pedestrian recording, or with online systems. Good. When I started, it was about one data set, because we were working with a company. So we were not able to publish anything about research. So we published the data set. The data set was used for indoor location. It set the format for other data sets. So now there are more than 70 data sets collected around the globe. It was a good choice for projects. We won some projects because we had that data set. And also we are using for training data scientists. It's perfect to test all the stages of machine learning, from data curation, data preparation, data analysis, training models, and analysis data. It's around 25K samples collected by 30 people and multiple devices. So it was not a toy data set. It was collected in 3 big buildings. Okay, the Wi-Fi fingerprinting is the past, so what is next? This picture is about the laboratory I was 2 years ago. And there are several people, but for instance, Fernando from the University of Extremadura was working on low-level localization, angle of arrival with technology. Then Sergio was using that information from positions to generate the routines of people at home or people that was living in a senior residence. So that if you can establish the routine, the daily routine of a person, you can detect in the future if there is any deviation, if there is any cognitive deviation in his behavior. And Miguel finally did a sensing approach to detect movement within the environment. I repeated the picture to mod later, and there were also new lines related to location. Here there is an example of how to use the channel state information from Wi-Fi to human activity recognition and location and positioning, and involving teams around Europe. I'm going a bit fast because I know we are running out of time. If that CSI information is compact, this multidimensional information is compact in an unsupervised way, we can reduce to 2 dimensions. And this is channel charting. And if we can map that, reduce it, that channel charting to the real world, samples that are closed in the feature space will be closed in the real space. So we can, in an unsupervised way, to generate a map from the radio signal to provide location. This is channel charting and this is Chaser. It's a Chaser project we are having with people from Aalto University in Rouen in France and the ETH in Zurich. Okay, we have also projects related to ultra-wideband in industrial scenarios to, let's say, use artificial intelligence to deploy the optimal infrastructure, minimizing the anchors. And with the current project, it's based on a Marie Curie. It's oriented. We are trying to provide indoor location with different technologies and trying to fuse them, to combine the different technologies in an intelligent way. Because what is working here, maybe is not working in that corner. So for that, we are using the event-based cameras with neuromorphic imagery, advanced Bluetooth low energy systems, ultra-wide systems, state-of-the-art, and also the newest smartphones and Wi-Fi technologies like Wi-Fi route trip topic. Instead of using the signal strength, we are using timing to get the location. And finally, art is for everyone, and this is because we are having a student from Rome here, and he's applying machine learning and interlocalization techniques for museums with location, recommender systems, and LLM to adapt the contents to display to the people. Here you have some videos where you can find some interesting works, and that's it.
Joaquín, we need to change the battery's microphone,
okay.
And for ask the questions, use
this microphone.
One. Any question?
Can you explain a little bit about this seamless position? What do you mean by seamless?
Yeah, because sometimes when we are talking about location, we are talking about outdoor location or indoor location. But when we are living, we are not living indoors or outdoors. Sometimes we need to transition from indoors to outdoors, and we don't need to focus on one technology or on one technique. We need to integrate them seamlessly, the different approaches that are available to provide location. Even if you are indoor, you are outdoor, you are, like, let's say, at home, or you are doing some exercise.
Have any question? Yes?
I saw somewhere, maybe in social media, like some kind of project that was about maybe using Wi-Fi routers as cameras that could like see like the, what is this called? The silhouette of the persons that were working around the Wi-Fi. I want to know about your thoughts on this topic and if it could be used.
You saw probably this word from Colorado that we are using, because now we have walls, no one from outside can see us. But this is not true, because they can use sensing, radio frequency sensing, and they can do a tomography image of what is indoors, because there are many signals disturbing the environment. We have positive comments and also negative comments about this. It is possible, we saw some works doing that, but what we have realized is that there is a kind of data leakage, because most of the experiments like this one about CSI and human activity recognition, they were using data that was collected very close in time. So if we start to measure here, train models, and evaluate the models with the data collected, let's say, in 10 minutes period, we will get very good results. But if we come tomorrow with different people, different distribution of the audience, the picture will be completely different. The signal's behavior will be completely different. So this is what we are investigating now. If there is a temporal component that we can remove to achieve what you saw in that paper. It was like a tomography image, what is endorsed from just the radio frequency signals.
Yeah. In Oxford, I have a colleague, Nikki Trigoni, and she has started Navenio, a company that does indoor location, and they seems that hospitals are very interested in this, to find doctors quickly if they are needed, etc. Is there anything similar here, or how does it compare to what you are doing?
In fact, I met Nikki Trigoni in Hong Kong this last October in IPIN conference, in one of the conferences I did. Yeah, it's in hospitals there are 3 problems. First is to find the doctors. Second, to find some instrumentation that is critical. And we don't need to know it's exactly in that corner.
Yeah.
Knowing only the room where it is placed is enough, because sometimes it's in a room in the opposite way of where you are. So there are opportunities, there are applications, and not only for finding doctors, for finding an instrumental, and also for the people that is waiting. Because sometimes the problem in hospitals is that they are waiting in the wrong waiting room. So, yeah.
But do hospitals use this? I have two questions, actually. So one is, do hospitals in Spain, for instance, or where you know, wherever you know it, use it? And the second question is, do doctors, do they want it, or is it unethical? Because I don't want the system to know exactly where I am, etc.
That's a good question. We tried with one hospital, but the hospital requirements was to don't deploy anything. And without deploying anything, it's impossible. So we wanted to deploy with a hospital in Catalonia, and it was impossible. But the solution was easier. The solution for the problem was for the people waiting in the wrong waiting room. And the solution was, instead of developing an application, was to put more indications, physical indications in the other. Because we have a problem in hospitals. Some walls are completely sealed. So even if you put the infrastructure, it's not, the range is so limited that it will not work. Then for the doctors, this is depending on the person. Some people are not prone to have this technology and to be tracked at every point.
Even Nikki Trigoni had problems in the UK, because the hospitals at the end, it didn't work out, and then she moved with her company, she had to move the company to the US to have more attraction there.
But then for locating critical instruments, it seems that there is less restrictions for that. Less concern, less privacy.
Thank you, Joaquín. Okay, thank you very much. And now, Jordi Linares from the Universitat Politécnica de Valencia is going to talk about mediators of complexity, the rise of AI-mediated interfaces in human-computer interaction.